Here's day 2. Convert the matrix to row echelon form and label the operations. In row echelon form, the first row begins with a 1, and then below the 1 is a 0 and a 0. The second row needs to have a 1 in this position, below that a 0, and the third row needs to have a 1 in this position. So we can create that using the Gaussian elimination technique. In order to eliminate this -2 so that it becomes a 0, we can take 2 times row 1 and add it to row 2 to create a new row 2. So let's write down what we have. The first row remains the same, but row 2 is going to change. So 2 times 1 is 2, and 2 plus -2 is 0. 2 times 1 is 2, 2 plus -1 is 1. 2 times 0 is 0, 0 plus 2 is 2. And 2 times 5 is 10, and 10 plus -10 is 0. Now we also want this to become a 0 right here, and so let's do another row operation. We can take -3 times row 1 and add it to row 3 to create a new row 3. Let's talk it through. -3 times 1 is -3. When you add 3, it makes 0. -3 times 1 is -3. When you add 6, it's 3. -3 times 0 is 0, and add 7 makes 7. And -3 times 5 is -15, and you add 14, and that's -1. Okay, we almost have what we need. We've got the 1 here with zeros underneath, and we even have a 1 here, but we don't have a 0 underneath. So that will be our next row operation. How can we eliminate this 3? We can go -3 times row 2 and add it to row 3 to create our new row 3. The first row does not change, and the second row is not going to change. But our row 3 will change. Let's talk it through. -3 times 0 is 0, and 0 plus 0 is still 0. -3 times 1 is -3, and add 3, and that makes 0. -3 times 2 is -6, add the 7, and that makes 1. -3 times 0 is 0, and add the -1, and that's -1. This is row echelon form. It has the diagonal sequence of 1s, and below those leading 1s are zeros.